Welcome to the UGC lecture series. This is on the subject computer science, e-Pathashala lecture series on computer science, and we are talking about the paper data structures. And in this particular module, we are going to talk about a particular type of queue which is called as priority queue, used in very many applications, and so we are going to look at priority queue and its applications. Okay. So, these are the people responsible for the creation of this module, and let us start off by defining the learning objectives of this particular module. So, here we are going to explain the concept of the priority queue ADT. Now, what we are doing here is we are defining a separate ADT for priority queue, because it is a separate important data structures, that separate specific definition. We could have used the queue itself, but we do not want to do that. So, we are going to define a priority queue ADT, and we are going to outline the various operations of priority queue, and we are going to explain the implementation of priority queue using what is called as unsorted and sorted sequence. We have not done this before, so we are going to look at the implementation from a different viewpoint, and we are going to discuss some of the applications of priority queue. So, these are some of the learning objectives of this module, and the keywords associated are obviously priority queue, sequence and sorting. So, let us now talk about queues and priority queues. Okay. So, the operations are on queue, NQ will enter a new element into the queue, DQ will remove the element that has been entered first into the queue. Now, we are introducing a slight variation which we call as priority queue. What is the slight variation? Priority will not be implicit, you can do it in many ways. You can use the time of entry, that is what is actually being done in queue. So, what are we doing in queue? We are enqueuing according to the time of entry, but here in priority queue we do not use a time of entry, but we explicitly state an ordering, and we expect the queue to behave depending on that, not on the first in first out. There first in first out means the time of arrival is given priority. Here we are given an explicit priority. So, that is the difference. So, what is the priority queue? It is a special form of queue from which elements are removed according to the designated priority. When they enter the queue, they are not they are in the normal queue and queue same way, but for priority queue the removing of the element is not based on the first in first out, but is based on a designated priority, not in the order in which they are entered. So, for example, you take a associate professor, professor, senior professor, assistant professor, these are elements, and items entered in the queue in sequential order, but will be removed in the order. So, it will be entered as 1, 2, 3, 4, but it will be removed in the order of 3, which is senior professor, because we are giving some designation importance priority. So, senior professor, then professor 3, 1, associate professor 4, and then 2, but it would have come into the queue in the order 1, 2, 3, 4. So, that is what we mean by priority queue. Now, what are the uses of priority? It is a printer queue. For example, you want to service jobs which have number of pages are less faster, then the number of jobs for which the number of pages is more. But if you do it in the order of arrival, this cannot be serviced. So, discrete event simulation, use simulation time as priority here, not the arrival time. Network routing, give priority to packets with strictest quality of service requirements. There are some packets for which there is quality of requirement, service requirement is very stringent. In those cases, you service those packets first before servicing other packets. So, you cannot base it on the time of arrival. Okay. So, this is the priority queue ADT. So, it is an abstract data type, just like we had stacks, queues, lists and so on. And in a priority queue, each item, now this is slightly different, each item which is called an element is also associated with two components, priority and data. Up to now we used in a queue we had data only. Now we are going to have an entry or an element which composed of two components, associated priority and data. Okay. So, the main action that must be very efficient in a priority queue is finding the item with highest priority. So, it could be maximum or minimum, we will come to that. Now, what happens here is in a queue the arrival is at the rear, you remove from the front. Now, you cannot remove from the front, you have to find the element that has the highest priority, whatever may be the definition of priority. So, finding that particular element with the highest priority becomes very important, and it has to be efficient. Now, priority queue is a collection of 0 or more elements, and each element has a priority associated with it. Unlike the first in first out, the order of deletion, we are talking about deletion only, from a priority queue, that means who gets served first, is determined by the element priority, the priority associated with the element and not with the time of first arrival. So, elements are deleted by increasing or decreasing order of priority rather than by the order in which they arrived in the queue, which we have already defined. So, store tasks using a partial ordering based on priority, ensure highest priority task is at the head of the queue. If that is so, then you can eliminate it that way. Keys in a priority queue can be arbitrary objects on which the order is defined. So, it can be that way. So, two distinct entries in a priority queue can also, the duplicate entries are also allowed. We always have a section saying what are the elements that are possible. So, the basis of priority queue is as follows. A priority queue ranks the elements by key with a total order relation, with a little bit of mathematics here. So, total order, the keys, every element has its own key and keys are not necessarily unique. These are the two things we are going to talk about in a priority queue. So, the mathematical concept of total order relation less than or equal to, it has a reflexive property, x is less than or equal to x. I mean, if x is less than or equal to x, the other x is also, it's a reflexive. It's an anti-symmetric property. Okay. So, if x is less than or equal to y and y is less than or equal to x, then it means x is equal to y, it is not symmetric. It is transitive, x is less than y and y is less than z, then x is less than z. This is typical mathematical reflexive antisymmetric and transitive property which we associated with the total order relation less than or equal to. So, now let us define operation performed on priority queues. Find an element, now this becomes a new very important operation because we want to find an element with the highest priority, insert, delete. So, there are two kinds of priority queues, one is called the minimum priority queue and the other is called the maximum priority queue. So, the minimum priority queue you find delete the element with the minimum priority. The operation will find and delete the element with the minimum priority, maximum obviously with the maximum priority. So, this definition is depending on how you define the priority, nothing else, but they are defined. So, maximum priority specification priority queue, what would be different from minimum priority queue? It would be, can you guess? It could be greater than or equal to or less than equal to, that is the only difference that would have. There are other examples in our daily lives that use priority queue. A typical example would be the Tirupati Darshan. In Tirupati Darshan what happens? Normally there are, for different tickets you have different queues, there are sets of priority elements that come together. Inside that priority set you have first in first out. So, this is a typical example of queue in everyday life, priority queue in everyday life. You also have this Tarkal passport, that is again a example of priority queue. You give additional money, then you are given faster, but there also inside that set we are following the first in first out. Now, there is a new definition which we are using here. It is not necessary you should define it like that, which is called as entry ADT, because now entry has to be this way. So, entries in a priority queue is simply a key value pair. We said that each is associated with a key and a value. So, priority queue store entries to allow for some efficient insertion and removal based on the keys. Okay. So, there are two methods associated with the entry ADT. You need not have this, but we are just defining it because we are talking about everything in terms of from the perspective of ADT. So, methods are key returns a key for this entry and value returns a value associated with this entry obviously. So, that is the entry ADT. So, what are the operations that you can do on a priority queue ADT is the next question we have to answer. So, the operations are size, return the number of elements in P, then is empty, test whether P is empty, insert item, insert a new element E with key K into the priority queue P, minimum element returns, this is like front, top and so on, it returns but does not remove an element of P with the smallest key. An error occurs if P is empty. So, this is just to find out the smallest key. Minimum key returns the smallest key in P and error occurs if it is empty. Minimum element will return the element, minimum key will return the key, that is all. Remove minimum will remove from P and return an element with the smallest key. Another condition will occur if P is empty. So, this definition is sort of only difference is that minimum business because we are talking about a priority queue. And then another important component you need for implementing priority queue is the comparator. So, a comparator encapsulates the action of comparing two objects according to a total order relation. The total order relation has already been defined for you. So, priority queues uses an auxiliary comparator. Unless you have a comparator, you cannot compare and see which is the highest or lowest, and it is external to the keys being compared. So, you can have the primary method is compare x comma y and it returns an integer I such that I is less than 0 if a is less than b or x is less than y, I is equal to 0 if they are same, and I is greater than 0 if A is greater than B. So, and an error will occur if A and B cannot be compared. So, compare x comma y or compare A comma B, we are assuming A comma B is given. So, it will return an integer which is less than 0, equal to 0, greater than 0, depending on the comparator is needed by the priority queue when it compares two keys, okay. And the comparator is it was given to do the comparison. The comparator ADT includes, it could be is less than or equal to, is equal to, is greater than or equal to, is comparable. So, all these are some of the operations that you can associate, all of these are Boolean operators, gives true or false for different types. So, it can be is less than, equal to, it depends on what application you are going to use the priority queue for, which in turn use this comparator. So, let us look at the implementation of a priority queue now. We are going to look at implementation with an unsorted sequence, okay. So, the elements of S are composition of two elements, key and element, and we can implement insert item by using insert last on the sequence, which takes 0 one time. This is when we are inserting, we are not bothered about the priority. So, here we have inserted 6. So, however, because we always inverse at the end irrespective of the key value, our sequence is obviously not ordered, that is why it is called unsorted sequence. Now, let us look at, thus for methods such as min element, min key and remove min, which we saw previously, we need to look at all the elements of S because it is in an unsorted order, okay. So, the worst case complexity of these methods therefore is of the order of n. For insertion it is of the order of 1, for all other methods it is of the remove, which is delete, finding the minimum element, finding the minimum key, it is of the order of n. So, you have to keep on putting it and then decide on, now you find 1 is the one minimum key assuming. So, this is the minimum key, and so we have to check everything to find out. You have to even go beyond 1 because it is in an unsorted sequence. Now, another implementation will use a sequence S which is sorted by increasing keys. So, then minimum element, minimum key and remove minimum will take 0 one time because you know that it is in the minimum will be in the front or in the rear or whatever, depend on how you want to talk about it. So, here it is in the this side. So, 1 is the element that you want, but when we want to implement insert item, you have to scan through the entire sequence. The worst case insert item will take 0 n because if it is greater than all the elements it will take 0 n. So, only here insert takes more time, but the other operations takes less time. So, this is implementation using a sorted sequence. Now, let us look at sequence based priority queue. Let us look at implementation with an unsorted list, the performance. Insertion takes 0 1 since we can insert the item at the beginning, and but all the others take 0 of the order of n. But in the implementation of a sorted list, insert takes of the order of n, but all the others take of the order of 1. As we saw, this is an important operation, so probably the second implementation is better. And the applications of priority queues, there are different type of applications for priority queues. For example, event driven simulation, for example, customers in a queue in a line colliding particles, data compression like Huffman's code, graph searching, Dijkstra's algorithm and Prince algorithm, operating system often used for load balancing and interrupt handling, and in discrete optimization it is used for bin packing and scheduling. We are not going to look at all the applications. So, let us look at priority queue sorting now. Okay. Now, a priority QP can be used for sorting a sequence. This is a different application. We are using priority queue for sorting a sequence, not use of sorting sorted sequence for implementing a priority queue. Please understand the difference. Here we are talking about a priority queue P which can be used for sorting a sequence S. So, insert the elements S into an initially empty priority queue with a series of insert KB operation, key and value, and removing the elements from P in increasing order, putting them back into S, which is the sequence that you want, with a series of remove min operations. So, if you do this repeatedly, you will get a sorted sequence. The running time for this sorting method depends on the what implementation you use for the priority queue. So, now let us assume that we are given a sequence S and a priority queue P, and we want to insert the elements of S into P with a series of P dot insert KV operations. So, let us assume we have P insert A1. So, you insert, and then you have A1. Now, you want to insert X7. So, you insert, remember you are inserting the elements into P using a normal sequence of operations. Then you insert again C2. So, that is inserted. Then you insert L5. So, that is inserted. We are going to insert some number of elements into the queue. So, we are just calling a series of insert KV operations. So, inserting elements, the value key of the sequence is appropriate one by one. So, again we are continuing with that. So, here again we are inserting T6, okay, and then we are inserting D3, okay, and then finally we are inserting K4. So, this is the insertion that we have done. Insertion one by one, one by one, one by n, always at the rear of the queue, normal operation, we are not doing any searching. So, this is the insertion into the priority queue one by one. Now comes the next operation, where we remove the elements from queue in increasing order and put them back into S with a series of remove min operations. So, what do we do here? We have this is the priority queue at the end of that insert set of operations or sequence of operations. Now, I remove the min element. So, I am from the P I am removing the min element. So, what is the min element here? That is A1. So, that is removed, and now this is the priority queue, and we insert it into the sequence. So, we have inserted. So, this is the first step. Now, here I am not telling which to remove, we have to remove the minimum element. So, let us look at the next one. So, here we have, now what do you have to remove? Automatically when I call remove min, it will remove C2. So, remove min will remove C2. So, that is the priority queue after that removal, and we have to insert it into the sequence in the normal order. So, we insert last. So, we have C2. Now, we have the priority queue from which we have to remove min. So, here we will remove D3. So, that is removed, and this is the queue after that deletion removal, and into the sequence at the last you will insert that. So, we insert. So, this is after inserting. Now, we continue. So, I remove min, I am not going to K4. So, K4 is removed from the priority queue and inserted into the sequence. Now, I have to remove L5. So, L5 is removed and inserted, okay, and then we continue. So, now I have this, I remove the min, I have to remove T6, I have to insert it, okay, and then I have to remove X7, and then that has to, now the priority queue is empty, and I have to insert it. So, that is inserted. Now, the sequence has the elements in the order, it is a sorted sequence. So, this is an example where the priority queue is used, where insertion is normal insertion, but removal is remove min, which is where priority queue is used. This is used for sorting a sequence. Now, let us look at another sorting, which is called a selection sort. So, in this what do we do? The priority queue is implemented as an unsorted sequence, and the running time of selection sort is inserting the elements into the priority queue with n insert operation, which takes of the order of n time, and removing the elements in sorted order from the priority queue with n remove min operations, which takes time proportional. Remember, as many elements as there are, you have to keep searching. So, it will take 1 in the first instance, 2 when there are 2 elements, 3 when there are 3 elements. So, the total time taken is for remove min is 1 plus 2 plus of n up to n. So, it is approximately the selection sort runs in of the order of n squared, because insertion takes for n elements 1 element of the order of 1 for n elements of the order of n, and for the removing it takes as many elements as there are it takes. So, the order of n squared. So, this is how it will happen. You will start with the sequence and the priority queue is empty, then in the phase 1 you insert it and the phase 2 you remove it. Now, you have insertion sort. Insertion sort is a variation of priority queue sort, where the priority queue is implemented as a sorted sequence. There we implement it as an unsorted sequence. So, running time of insertion sort, inserting the elements here will take 1 plus 2 plus that series, that much time it will take, because n insert operation we are inserting in sorted order, but removing is taking minimum time of the order of n elements you have to remove of the order of n. So, again the insertion runs in of the order of n squared time. So, selection sort, instead of using an external data structure, we can implement selection sort and insertion as sort in place. A portion of the input sequence itself serves as the priority queue. For in place insertion sort, we keep the sorted the initial portion and we use the swaps instead of modifying the sequence. That is what we do. So, here we have 5, 4, 2, 3, 1. Now, 5 and 4 are swapped. So, you have 4, 5, 2, 3, 1, and then 5 and 2 is swapped, and then this is swapped. So, finally, you have the sorted sequence. This is a selection sort. Okay. So, we explained the concept of priority queue and priority queue ADT in this particular module, and we outlined the various operations of priority queues, and we explained the implementation. It is very interesting that we did here. We used two types of sequences, unsorted sequence and sorted sequence, to implement the priority queue. And we saw that the via media was, one insertion is very fast, the other deletion is removal, we call remove min, takes time. Otherwise, if you use sorted, the other way around, insertion takes more time, but remove min is takes minimum time, of the order of n. So, and we discussed various applications of priority queue, especially in the from the perspective of sorting. We saw selection sort and insertion sort in this particular module. So, here we have used, we have explained a special type of queue ADT, which is the priority queue ADT. Thank you.